This is some differentiation using the chain rule, specifically stuff with e to the x and ln x, and it's just a couple of extra examples here. So let's take a wee look at the first one. It says find dy by dx. Normal standard form for the chain rule is we would let u equal this power up here. So we're going to let u equal 3x squared plus 1. That means we can rewrite our y equals 2e to the u. dy by du, nothing changes there. That gives me 2e to the u. Of course, if there's 2 up here, you'd be multiplying by 2, but this 2 doesn't affect it. It's just a number out the front. And then we have du by dx here, which is going to give us then our 6x. dy by dx equals dy by du times du by dx. dy by du is 2e to the u, and we're multiplying that all in by the 6x. So that 6x can come to the front. That's going to give us 12x e to the u, which is then 12x e to the, remember we let u equal 3x squared plus 1. So we change it back for that. So that's that one. Second example then, let's take a look. Again, we're asked to find dy by dx. So an awkward enough one here. Y equals, I would rewrite this as 5e to the minus x squared. I hope you see what I've done there. Minus 2x cubed. This bit's dead straightforward. That's just going to be 6x squared. This one here we need to kind of take off to the side. I'm going to just write it over here. And take a wee look about how we do this. So say we have y equals 5e to the minus x squared. I would let u equal minus x squared. That would give me du by dx down here, which is minus 2x. That gives me y equals 5e to the u. As with our previous example, nothing really changes here. Dy by du is 5e to the u, and dy by dx is dy by du times du by dx. So our dy by dx in this case is going to be 5e to the u times by our minus 2x. So that's going to give us a minus 10x, and then e to the minus x squared. So we're pretty much there. Dy by dx, then in this case this differentiated, we've just worked it out down here, so let's copy it in. Minus 10x e to the minus x squared, and then differentiating that gives us minus 6x squared. Final example. Is on ln x. So again, we're going to get y equals ln u, because we're going to let u equal to 2x squared plus 3x. If we differentiate dy by du equals 1 over u, du by dx equals 4x plus 3. Dy by dx then is dy by du multiplied by du by dx. So dy by du times du by dx, or I should really have written that the other way around, but that's okay. So that 4x plus c is going to go up to the top, 4x plus 3, and then the u, which we just changed then, is 2x squared plus 3x. That's our dy by dx. Now you notice this all the time with ln functions, and it's very handy for doing integration a little bit later on in the year. If you differentiate the bottom line, you will get the top line. That's the way all of the ln functions works. And that's our example.